Okay, so what are some factors you may not know, but your parents know? What do you think your parents think about when they're choosing a plan for your family?
Price?
Yes. Anything else?
How many people you put on the plan?
Okay. Something that you had to think about in Manchester, Tennessee is the reception. So it's not smart to get a plan where you can't use your phone. All right, and so let's say that we have this Metro by T-Mobile offer, and a person uses 1.7 gigabytes of data. How much would their monthly bill be? Mm-hmm. What about 3.5? I think I heard it. 45. Yeah. All right, then we're going to do a graph. And so between when x is 0 and x is 2, you are going to just pay $30. So I saw a whole lot of people had this right, where there's just a horizontal line there. And then from that line on, it's going to be a slanted line. And each gigabyte, how much does it go up by? 10. And so I did see a lot of people just had the dots, it's fine. But you do want to connect the dots, because if you do use a partial gigabyte, then you still have to pay for that partial. Okay, and then this last part is a part I don't think you really know how to do. It's fine. You learned about these type of functions in Algebra 1, but you probably didn't do much more than just evaluate them and maybe graph really, really basic ones. These are called piecewise functions. And this one has two pieces. And so that first piece, no matter what, the y value is going to be 30. So you have to give, the rule or the equation for that piece. And then you also have to tell what part of the domain you use that piece for. So how can you describe the values that you're going to get 30 for? Yeah, I'm glad you understood that, because I felt like I said it was super weird. All right. Do you include 2? Yes. You can include 0. I don't think anybody would really get a phone and never use it, but if you did, you'd still have to pay $30. All right, the second piece is the piece that's difficult to do. Any ideas? There is a 10.
Would it be x times 10 plus 30?
Close. Okay, so this is an option that's not quite right. So let's leave a little bit of a space. And a lot of you probably thought this, and it's normal. What is wrong with this as the answer?
Because if you just plug 1 in,
Right, if you plug 1 in, you get 40. So basically what that is this line right here, which is just too much. So you're paying $10 for these also? So you're kind of paying for those twice. So how can you fix it so you're not paying for those minutes twice? Subtract those minutes away. Good job. All right, and then how can you describe this domain, the domain you would use this for?
Everything to the right of 2.
Yes, or x is greater than 2. Very, very good. All right, do you guys remember when we learned how to write the equation of a secant line? We're going to have to remember that soon, either this week or next week. That's going to come back up. It's actually going to come back up today. And so what we did is we would say that y is equal to y1 plus m times x minus x1. Do you remember that? Hope so. You will. So that's kind of, well, that's exactly what we did. Our x1 and y1 was the point 230. And so this was the y1. Your slope was 10. And then the x1 was the 2. So So we kind of logicked our way to do something that we already kind of knew how to do. All right, so that's the piecewise function. They're super fun. I wish you knew more about them before today, but that's okay. You're going to learn a lot today. All right, so on the notes part, sometimes they're just called piecewise functions. Sometimes they're called piecewise defined functions. It means the same thing. But on these functions, you have different rules for certain intervals of the domain. All right, so one thing we're going to do today is evaluate piecewise functions. Bless you. We're also going to graph them, which is kind of what you did on the cell phone. And we're going to write the piecewise function, which was what we did on the last part of the cell phone. So evaluating is definitely the least difficult out of those three things. So all you have to do to evaluate is determine which interval your input belongs to. All right, so that's just looking at this part right here and deciding if the value you're putting in falls between 0 and 3, or it falls between 8 and 28. So that's all that is, just making a decision about what piece to use. And then you substitute the input into that piece only. So when you're evaluating, you're going to put one thing in, and you only get one thing out. You can't put it into every single piece. That doesn't make a function. So you should only put one thing in and only get one thing out. All right, so this first example is another application about buying pizza. So Pizza Palace is offering a promotion. The cost of a large pizza in dollars as a function of time measured in days since October 20th can be described by this piecewise function. And so on on number 1, it has the price of a pizza on Halloween. So what is T on Halloween? It should be the number of days since October 20th.
11.
Yeah, 11. That's why I said 11. My brain is a little slow this morning. Okay. And so for T equals 11, how much would this pizza cost? Yep. So because 11 falls between 8 and 28, that pizza is going to cost $18. Okay. And then number 2, on what days should you go to Pizza Palace to get the best deal? What day is pizza going to be the cheapest? Sorry.
0 to 3.
0 to 3, or October 20th to 23rd. It's a pretty cheap pizza. All right, and then for number 3, we want to find C of 9 minus C of 8. So let's just start with C of 9. Which piece are we going to use for T equals 9? The bottom one. So C of 9 is going to be 18. All right, C of 8 is a little more challenging, but I think you can figure it out. There's 2 pieces that have 8 in the domain. So how do you decide which one to use?
What's that equal to?
Yeah, the one, very good. The one that has the or equal to is the one you would use. So this is going to be 7 plus 8, or 15. So the question wants us to find C of 9 minus C of 8. So that's just going to be 3. And then interpret the result in the context of the problem. So what is 3? It's $3. Not for a piece of pizza. That would be a really good deal if it was $3 large piece.
$3 cheaper.
Cheaper. So it's $3 cheaper to buy it on the T equals 8 than T equals 9. So buy it on the 28th instead of buying it on the 29th. All right, what is the significance in the domain restriction? So this is only from when t is 0 to when t is 28. What does that mean? How long is this sale going to go on? 28 days sale. Then back to normal pizza prices. Technically it's 29 if you count 0. It's okay, it doesn't matter. All right, so then we're going to do a little sketch of this graph. So the first piece is 7, and the function equals 7 when t is between 0 and 3. So 7 between 0 and 3. Now on these piecewise functions that the pieces don't connect. So the one we did with the cell phone, the pieces connect, and so this didn't really come up. But if they don't connect, you have to decide if you have open or closed circles at the endpoints of your pieces. So what do you guys think about this piece? Are these endpoints going to be open or closed circles? Closed circles, because both of the sides of the domain have the or equal to bar. Good job. All right, so that's a little horizontal line. The next section is going to be a slanted line. And so what I'm going to do is I'm just going to find the values at the endpoints, and then I'm going to just connect them. And so if I put in 3 into that piece, what would you get? 10. Is that going to be open or closed? Open. So it's going to be 3, 10 with an open circle. Have we already plugged in 8? We did. We plugged in 8 and we got 15. So I already know that's going to be 15. And I also know that's going to be a closed circle there. And then we just connect the pieces. Or connect the dots. Connect the endpoints. All right, and then our last piece is another horizontal line at 18. And it starts at 8, but we don't include 8, so it's going to be an open circle. And then it's going to go all the way to 28. We also include it. There it is. All right, any questions? Okay, so let's look on the back. So these ones don't have any kind of real life application attached to them. They're just piecewise functions. And so on number 6, we're going to evaluate it. So we just decide what piece we're going to use and then plug the value in for x. So for -10, which piece are we going to use? Well, I think you might have said it. I just didn't hear you. The top piece, good. And I want you guys to try and do as much as possible without a calculator. If it's one that, like, I know there's one on your assignment that's got a bunch of decimals in it, it's fine. I don't want you to waste your time multiplying decimals. That's annoying. But this, we can definitely do in our head. All right, so f of -10 is just 14. Sure. All right, then we're going to plug in -2. What piece are we going to use for -2? Second one, good. -2 falls between -6 and 2. All right, and then you guys try the last one on your own, f of 2. -6 again. So we're going to still use that same one. And even though there's two numbers with 2, we have to use the one with or equal to. So we should get -6 again. All right, any questions so far? Yes, ma'am.
So why would you put the F2 also in the same one as the F2?
Because even though this one has a 2, we don't use it for 2 because it doesn't include it. If it equals 2, we have to use the middle one. Right, any other questions? She probably wasn't the only person wondering that. Okay, and the next one we're going to graph a piecewise function. So when you're graphing them and it's all linear line segments, it's pretty simple to do. This one is not going to be all linear, so it's going to be a little more challenging. Is this first piece going to be linear? Yes. What about the second piece? No, that's going to be a parabola. And when it's a parabola, you might have to do a little extra stuff. And then this last one is also going to be a line. So when I graph piecewise functions, I just do like a separate little thing for each piece. So I would start with -2x minus 8. And then whatever these endpoints are, I'm going to plug those in. So this is different from evaluating. When we're evaluating, you wouldn't plug the -3 in for that one. That's not what we're doing. We're graphing it. So what we're going to do is just find the endpoints and then just connect them with a line. So we can do this in our head. When we plug in -7, what's -2 times -7? 14. And then -8? 6. And then is that going to be an open or a closed circle? Closed. Good. So because that -7 has an or equal to, that endpoint is going to be closed. Right? And then we'll do the same thing with -3. So we do -2 times -3 is 6. -8 is -2. And then this one, it doesn't have the or equal to, so it's going to be open. And I'm just going to go ahead and graph that little line segment. Right, and then we'll do the same thing for the middle piece. We're going to plug in -3 and we're going to plug in 2. So it's a little more difficult just to straight up do in your head. So if you need to write it down, it's okay. So this negative in front of the squared seems to mess people up a lot. Would I multiply the negatives together first and then square, or would I square first? Square first. So -3 squared is -9. So that's going to be a -5. And because it has the or equal to bar, it's going to be a closed. Right, and then we would plug in 2. So -2 squared is -4 plus 4 is 0. And it's going to be open. Now, it is important that you don't connect those with a line because this is a parabola. Bless you, bless you. And if you just kind of remember the things about transformations, you might be able to kind of know what this parabola is going to look like. If you don't, it's okay. You probably just want to plug in another point. What's an easy point to plug in? You can plug in 1. I think 0 is a little easier. If I plug in 0, I get 4. Alright, and so then you can kind of see that this is going to be a parabola. It's upside down. Alright, you guys do the last piece on your own, please. Alright, any questions? Alright, and then the very last thing we're going to do is write the rule for the piecewise function. I feel like if you can do this, then you really understand piecewise functions. So we have this one, it's called f, so we're going to call it f. And then you have to do this brace that apparently you have to be a teacher to be able to draw. It's a qualification. Alright, so we have 3 line segments we're going to draw, or we're going to write little equations for. This first one, I recommend that you just use the secant rule, or the secant line rule. And you have the option. You can use any point on this line as your x1 and y1. Last class we just used this one, that was -5, 5. But we can use any of them. What do you guys want to use? -5, 5? Okay. And so we start with y1. y1 is going to be the 5 from -5, 5. This is x1, this is y1. That doesn't look like a 5. All right, and then to that we're going to add the slope. So what is the slope of that line? Yeah, good. So what I do when I find the slope of a line is I just find 2 points that are exactly on the line. It's down 3, right 1, so that's -3. So instead of doing plus -3, I'm just going to do -3 if that's okay with y'all. And then what should I put in the parentheses? X minus -5?
So it'd be x plus 5.
Good, good, good. Nice job, guys. All right, and then we also have to give the domain that we use this piece for. And it's from -5, and we include it, to -2, and we don't include it. All right, and then this middle piece, I think it would be easier if we just do slope-intercept form. So if you can see where it crosses the y-axis, it's a little bit easier, maybe not that much easier, but I just wanted to remind you of slope-intercept form. And so if we're looking at that middle piece, what is the slope? Not 2. It's 1/2. Because you're up 1, right 2, up 1, right 2. So 1/2 x. And then what's the y-intercept? 2. And that's all you have to do for slope-intercept form. So, slightly easier. All right, and we're going to use that piece when x is between -2 and 2. We include -2, but don't include 2. Alright, and then horizontal lines are my favorite. So if they're the easiest, so it's just that last piece is always going to be 4. Alright, and you guys write the domain for it for me, please. Alright, what questions do you guys have about piecewise functions?